Nice and stable in. Showing the light of that. Oh. Hello. Try to say something like. Hello. Hello. Yeah, you can start. Good morning. Today we starting tutorial sheet 4. Today we starting tutorial sheet 4, and this is MSM. We're doing MSM 111 tutorial sheet 4. So make sure that you have tutorial sheet 4. So now let's start. Okay. Tutorial sheet 4, question 1. We are saying solve the each of the following equation. So equation, let's solve question 2. Question 1, question 2. We solve question 1, question 2. We have 1 over 2 to the power x equal to 1 over 16. So now solving a question like this one, meaning we have to solve for x minus even using gloves. So what is it that we're supposed to do? We all know that the 2 to the power 1 is equal to 2. And if we say again 2 to the power negative 1 is equal to 1 over 2. Same applies to 16. 16 to the power 1 is equal to 16. And the 16 to the power negative 1 is equal to 1 over 16. So following the question, we have 1 over 2 to the power x equal to 1 over 16. So this 1 over 2 can be written as 2 to the power negative 1. Then you do that, you say to the power x equal to, the 1 over 16 can also be written as 16 to the power negative 1. So our aim is to solve for x. So how are we going to solve for x? We have to make the bases look the same. We have to make the bases look the same. So what is it that we're supposed to do? We know that 2 is the multiple of 16. So we can change 16 to base what? To base 2. So changing 16 into base 2, we can do this. We say 2 to the power negative 1, here x equal to 2 to the power 4. You do that to the power negative 1. The 2 to the power 4, it means you can multiply 2 4 times for you to get 16. That's 2 to the power 4 you see in there. So now from there, let's multiply the powers now. We have 2 to the power, if we multiply negative 1 by x, we're getting negative x. Equal to, if we multiply 4 by negative 1, we're getting 2 to the power negative 4. Now, since we have same bases, we can equate the exponents. So now, equating the exponent, we're getting something like this. Negative x equal to negative what? 4. So in this way, it's easy now for us to solve for x. So what we're supposed to do here is to say over negative 1, you divide both sides by negative 1. We cancel there. X is equal to 4. So that's what you're supposed to do when you're dealing with a question like that one. So that's question 1, Roman numeral 2. So let's solve another question based on the same. Let's pick question 3. We pick question 3. Question 3. Let's pick question 3. So question 3, we have 27 to the power 4x equal to 9 to the power x plus 1. This is question 3. So we have 27 to the power 4x equal to 9 to the power x plus 1. So as you can see, with different bases. There we have 27, here we have 9. So now what you're supposed to do here for you to solve for x, you have to convert base 27 and base 9 to a common base. So now we know that 3 is the multiple of 27 and 3 is also the multiple of what? 9. So we can change, meaning our common base there is what? Is 3. So in short we can say 3 to the power 3, you do that, to the power 4x equal to 3 to the power 2, you do that to the power x plus what? Plus 1. The reason why we're saying 3 to the power 3, because if you multiply 3 times, you get to 27. Even there, the reason why we're saying 3 to the power 2 is that if you multiply 3 2 times, you get what? 9. So now let's see, let's multiply now the powers. We multiply the powers, so multiplying the powers we're getting 3. If you multiply 3 by 4, you're getting 4x equal to, again you multiply, so it means there we have 2 x plus what? Plus 1. So let's proceed with 3 to the power 4x equal to 2 by x, we have 3 to the power 2x plus what? Plus 2. Now since we have some bases, we have now to equate the what? The exponents. So now equating the exponents, we're getting 4x equal to 2x plus 2. That's what we're getting. If we equate the exponents, we're getting 4x equal to 2x plus 4. So now let's solve for x now. 4x equal to 2x plus 2. So now you say 4x, this implies that. So if this 2x crosses the equal sign, we're moving negative 2x equal to 2. So if you subtract here, you're moving something like this. 4x minus 2x, we're getting 2x equal to 2. Then you divide both sides by 2. You say over 2, even there over 2, you cancel. So x is equal to 1. So that's what you're supposed to do, and that's question 1, Roman numeral 3. That's what you're supposed to do. Let's proceed. Let's proceed. Question 2. Question 2, the question is saying sketch the graph of each of the following function. So now let's do question 1, Roman numeral 1. 2, Roman numeral 1, we have f of x equal to 3 to the power x. F of x equal to 3 to the power x, f of x equal to 3 to the power x. So f of x equal to 3 to the power x. Now let's solve this one. So sketching this one, you have to consider the table of values. Very important. So table of values, we say x and there y. So now you can choose the numbers that you can play with. Like as in for me, I've chosen -2, -1, 0, 1, and 2. So now if we substitute where this x we put -2, we're having something like 1/3. Again, where this x if we put 1/3 to the power 2, yes. So now let me just do this. We're having something like 3 to the power -2, which is equal to 1/3 to the power 2. Also equal to 1/9. If we substitute again, we say where this x we put -1, we're having something like 3 to the power -1, which is equal to 1/3, which is equal to, or just 1/3, yes. So if we put 0 there where this x, we put 0, we are having 1. If we put 1, we're getting 3. If we put, we substitute there, we're getting 9. So now since we have the values there, we can now sketch. So sketching is simple. So let's do this. Sketching is simple. So x, we have -2. So we assume -2 is there. So -2, 1/9, which is 1.111, the point is somewhere there. So again we have -1, we assume -1 is there. So -1, 1/3, that's 0.3333. So it's somewhere there. And again we have 0.1, 0.1, the point there, 0.1. Then from there we have 1.3, we assume 1 is there, then 3 is somewhere there. And again we have 2.9, we assume 2 is there, then 9 is somewhere there. So the graph that we are having here is this graph. So that's our graph. You even indicate to say f of x equal to 3 to the power t x. So this graph, it has the y-intercept of 0.1. It has the y-intercept of 0.1, so that's our graph. So now let's proceed. We do another question based on the same. Let's solve another question based on the same. Okay, let's pick question 4. Question 2, Roman numeral form. 2, Roman numeral form, IV. So now let's try to sketch this one. We have f of x equal to 2 to the power negative modulus of that, modulus of x. So now solving this question is also simple. It's very simple. So what you're supposed to do here, you're supposed to say f of x is equal to, so this one can also be written as 1/2 to the power that. So now from there, now we use the table of values. Table of values. Let's use the table of values. So using the table of values, let's do this. We have x there, we have y there. So now we choose now the numbers that we can play with. So I'm choosing -2, -1, 0, 1, and 2. So those are numbers I'm choosing. So now from there, let's substitute and see what we're going to get if we substitute. Let's substitute and see what we're going to get. So there we have -2. So if we put -2 there, Because of the modulus, it will be positive there. So we're moving something like 1 over 2 to the power 2. Because of the modulus. Or let me just say, make it clear. Let me just make it clear. We say 1 over 2, then to the power negative 2. So which is just the same as 1 over 2 to the power 2, which is equal to 1 over 4. So now from there we continue. We substitute again. Where there's x here, we put negative 1. So now let's substitute and see what we're going to get. So substituting with 1 over 2 to the power, we say negative 1, which is just the same as 1 over 2. Yes. So now from there, we continue. 0, we substitute if we substitute 0 there, we're getting 1. We substitute 1, we're getting 1 over 2. If we substitute 2 there, we're getting 1 over 4. So as you can see, the y side, we don't have a negative number. We don't have a negative number. Why? Because of the modulus. That's the reason why we're not having a negative number. So now let's proceed. Let's sketch this one. We sketch this one. So you do this. You do this. So you assume your negative 2 is there. That's your negative 2. So 1 over 4. What is 1 over 4? That's 0.25. So 1 over 4 is 0.25. So now leading your point is somewhere there. So now let's sketch that one with negative 1, comma 1 over 2, which is 0.5. So you assume your negative 1 is there. So comma 1 over 2, it's 0.5. So you have your point there. So if you want, you can put stars. There's no problem. So now from there, let's plot. Let's sketch that one. 0.1, 0.1. The one we assume it is there. So again, this one we are having 0.5. We say 1.0.5. If you do that one, we're having 0.25. So that's 2 and that's 1. So now let's sketch. Yes. So now we're having that graph. So that's the graph we're having. You even indicate to say this is f of x equal to this is f of x equal to 2 to the power negative modulus of x. So that's what you're supposed to do. That's what you're supposed to do. So it's simple, unless if you decide not to understand. But it's very simple as you see it. So now let's proceed. Let's proceed. So the remaining questions, make sure that you solve them. Make sure that you solve them. Let's do question 3. Question 3. So question 3, the question is saying, suppose that in a certain bacteria culture, the equation Q of T is equal to 1000 e to the power 0.4 t, expresses the numbers of bacteria present as a function of time t, where t is expressed in hours. How many bacteria are present at the end of 2 hours? So now let's pick question 1. Question 3, Roman numeral 1. How many bacteria are present at the end of what? At the end of 2 hours. So this question is not difficult. Or what you're supposed to do, you have the equation. The equation is there. you have Q of t equal to 1000 e to the power 0.40. So meaning your t there, meaning your time is equal to 2. So all what you have to do here is to substitute. There's nothing difficult there. What you're supposed to do is to substitute. So now let's substitute and see what we're going to get. So substituting, you say 1000 e to the power, you say 0.4. What is t? T is now 2. You say 2. From there, so if you multiply there, the answer that you're going to get, that's our final answer. So that's what you're supposed to do. That's question 3. Let's move. Question 4. Question 4. So let's do question 4. The question is saying, suppose that a certain substance has half-life of 20 years. So even there, as you can see, the equation is there. We have the equation. So now let's consider the equation there. We consider the equation that we have there. We have Q of t equal to 2500 multiplied by 2 to the power negative t over 20. So now the question is, how much remained after what? Let's do it after 40 years. Roman numeral 1. How much remained after 40 years? It's also simple. After 40 years. So the equation is there. So what you're supposed to do is just to substitute time. So you say t is equal to 40. So if your t is equal to 40, it's simple. Let's solve it. Let's solve it and see what we're going to get. We are saying t is equal to 40. And we have that. We have Q of t equal to 2500. Then we do that t 2 to the power t over what? Over 20. So now we are saying t is equal to 40. Let's substitute and see what we're going to get. So we have 2500 to, what is t? T is what? 40. You say 40 over 20. So we have 2500. 2500. You can divide there. So you say 2 to the power negative 2. If you divide 20 into 40 2 times. So now it means we'll have something like this now. 2500. So the 2 to the power negative 2 can also be written as 1 over 2 to the power 2. So let's proceed. We have 2500. Then you do that, you say 1 over. What is 2 to the power 2? 2 to the power 2 is 4. Simple. So 2 to the power 2 is 4. You do that. Then from there, you say 2500 divided by 4. So what is 2500 divided by 4? If you divide there, you say 4 into 25. How many times? 6. So you're getting 6025. So that's your answer. That's what you're supposed to do. That's what you're supposed to do. So that's question 5. So even the remaining questions, do the same. It's easy and simple. Let's proceed. We proceed. Question 5. Question 5, the question is saying, write each of the following in logarithmic form. So question A. So question 5, we are saying 5 Roman numeral 1. Let's pick question Roman numeral 1. We have 10 to the power x plus 1 equal to y. So 10 to the power x plus 1 equal to y. 10 to the power x plus 1 equal to y. So solving this question, we know that, recall that the following are equivalent. So if you have z to the power y equal to x, so this one is equivalent to y equal to, so we are saying it is equivalent to y equal to, you say log z x. So what you're supposed to know here is that x is your answer. And what's that y? Y is the exponent. Y is the exponent. What is z? Z is the base. Z is the base. So you say, so now this is, the first one is in the exponential form. So in logarithmic form, so it means you're having, the answer that you're getting there is exponential, exponent, then base, and answer there. So now let's use that concept as in to solve this one. So we have 10 to the power x plus 1 equal to y. So what we're supposed to do here is just to collect data. Let's collect data and see what we're going to get. So now you say data for easy calculation. For easy calculation, you say data. What is your z? So you say z according to this question, z is 10. Our z is 10. Our y, according to that question, y is x plus 1. So your y is x plus 1. That's your y. So now, what is now x? Your x is y. So now, since we've collected data, so now we can substitute. We are saying z to the power y equal to x in exponential form is equivalent to y equal to log zx. So now let's use this one because we want to change this one into logarithmic form. So now we're using this one. So we have y equal to log zx. Y equal to log zx. So now what is y according to this question? Y is x plus 1. Your y is x plus 1. So you say x plus 1 equal to log, what is z? Your z is 10. So you put 10 there. What is x? Your x is y. Your x is y. According to that question. So now we say x is y. So that's your final answer. That's your final answer. Or if you want, you can say log 10y equal to x plus 1. So that's your final answer. That's what you're supposed to do. So if you feel this method is difficult to you, so let me show you another method, as in the method that you can use. So let me show you another method you can use. So if you feel you can't manage collecting the like terms, the other method that you can use to solve a question like this one is this. So now let's do this. Where is the question? The question is there. We have 10x plus 1 equal to y. 10 to the power x plus 1 equal to y. So the other method that you can use is that you have to consider the base. If your base is 10, then multiply both sides by log 10. If your base is a, multiply both sides by what? Log a. So now, following the question, we have our base is what? Our base is 10. So meaning, we're going to multiply both sides by what? Log 10. So now you say, log 10 to the power what? X plus 1 equal to, again, even the other side, you say log 10 y. So now, let's deal with this one, the left-hand side. We have log 10 x plus 1. Recall that for any real number p and another real number r, we have log a p to the power r equal to r log what? Log ap. So we are going to apply that through here. So what's our power? Our power is x plus 1. Our power is x plus 1. So now let's do this. You drop the power there. You say x plus 1 log 10 equal to log 10 what? Y. So x plus 1 log 10 equal to log 10 y. And we all know that log a is equal to what? 1. So our log a is equal to 1. So now it means log 10 is also equal to what? To 1. Let's do that. So xc plus 1, and that's 1 now. We get to log 10 is equal to 1, equal to log 10 y. So we have x plus 1 equal to log 10 y. As you can see, we're getting the same answers. So even if you use this method, there's no problem. Even if you decide to use that method, there's no problem. So we're getting the same answers. Log 10y equal to x plus what? Plus y. So if you feel you can't manage, what? You can't manage collecting the like terms, the other method that you can use is that one. So that's the method you can use. So let's do another question based on the same. So another question based on the same. Let's pick question. Let's pick question 4. We pick question 4. So question 5. 4. We have 10 to the power negative 4 equal to 0.0001. So now, let me say we use two methods. Let's use two methods here. So we say method 1 and method 2 there. So we start with method 1, where we're saying z to the power y equal to x is equivalent to, you say, y log zx. So we collect data now. the question is there. We have 10 to the power negative 4 equal to 0.0001. So now let's collect data. According to that question, our Z is what? So our ZD is 10. So you say ZD is equal to what? 10. What is Y? Y is equal to negative 4. And our X is what? Our X there is 0.001. Now what's our M? Our M is to what? To write that one in what? Logarithmic what? Form. So now let's do that. Let's do that. Since we've collected data, let's do that. So ZD is equal to 10, Y is equal to negative 4, X is equal to 0.0001. So now we're using this one. What is Y? Y is equal to, so let's do this. Let's write the formula first. Y is equal to negative 4. So you write negative 4. You do that. Y is equal to negative 4. So now from there, you say log. What is ZE? ZE is equal to what? It's equal to 10. You write 10. Then what is X? X is 0.001. So you can also conclude to say log 10, 0.0001 equal to negative 4. So that's our final answer using method 1. So that's our final answer using method 1. So let's proceed. Let's use method 2 and see what we're going to get if we use method 2. So, okay, so we say method 2. Method 2. So we have 10 to the power negative 4 equal to 0.0001. 10 to the power negative 4 equal to 0.0001. So method 2, you have to consider the base there. If your base is 10, it means now you have to multiply both sides by what? Log 10. If your base is 10. If your base is E, multiply both sides by what? Log E. So in this case, our base is what? Our base is 10. So now let's multiply now both sides by what? Log 10. So multiplying both sides by log 10, we get now reading something like this. Log 10, 10 to the power negative 4 equal to, again, even the other side, you say log 10 multiplied by, so log 10, 0.001. So what is just important here is to identify your base. If your base is 10, multiply both sides by base 10. If your base is E, multiply both sides by what? By E. So now let's continue. We use the rule that we used. So now we say we drop the power there. You say negative 4. Then you do this. Log 10, 10. So you have something like that. Negative 4 log 10, 10 equal to what? Log 10, 0.0001. So now let's continue. What is log 10, 10? Is 1. We know that. Log 10, 10, log A. Log A is equal to what? 1. So now there it means we're having something like this. Log 4 by 1 is just negative. Negative 4 by 1 is just negative 4. So now from there, you say equal to, because log 10 is 1. So now 1 multiplied by negative 4, that's the negative 4 you're seeing there. 1 multiplied by negative 4, it's negative 4. So there you go, log 10, then 0.001. So in conclusion, you can say log 10, 0.0001 equal to negative what? 4. Have you seen? We're getting the same answers. The first method, we got log 10, 0.0001 equal to negative 4. Even the second method, we have log 10, 0.00001 equal to negative 4. So if you feel this method is difficult for you, you can use the other method. If you feel method 2 is difficult, you can also use method 1. So let's solve another question. I think the last question. Let's solve another question. Okay. Let's pick question 2. 5 Roman numeral 2. So 5 Roman numeral 2, we have e to the power x equal to y. E to the power x equal to y. So meaning our base is what? Our base is e. Our exponent there is what? X. And our final answer is what? Y. So now let's do it. So using method 1, we're saying if you have something like that, our final answer should be x equal to, so if you have z to the power y equal to x. So this is equivalent to, in logarithmic form, we can say it's y equal to log zx. And we know that x is our answer, y is our exponent, z is our base. So now let's collect data. The question is there, e to the power x equal to y. Let's collect data. So data collection. So according to that question, our z is equal to what? Z is equal to e. That's our z. Our y is equal to what? X. And our x there is equal to what? Y. So we're using this one because we're changing this one into that. So now let's do this. We have y equal to log zx. The data is there. Z is equal to e, y is equal to x, and x is equal to y. So now what is y? We say y is x. So y is equal to x. You say x equal to log. What is z? Z is equal to e. So now what is now y? Our x is equal to what? Is equal to y. So in conclusion, you can say e to the power e log e y equal to what? X. So that's our final answer using the first method. So let's use the second method and see what we're going to get. It's simple. It's very simple. Let's use the second method and see what we are going to get. So we have e to the power x equal to y. So if you want to use the second method, identify your base. So identifying the base is what is as important here. So our base is what? Our base is e. So if your base is e, meaning you have to multiply both sides by what? Log e. So following this question, our base is e. So it means we are multiplying now both sides by what? Log e. So now let's do this. Log e, you say e to the power x equal to, again you say log e y. So that's what you're getting. You apply now the rule of logarithms. So from there, it means with x, you drop the power, log e equal to log e y. That's what you're getting. So now from there, we all know that log AA is equal to 1. So since we have log EE, it means that's 1. That's 1. So to say that's 1. So equal to log what? Log E y. Because 1 multiplied by x, we're getting x. Unless if you say 1 multiplied by x is x squared. But 1 multiplied by x is x. So x equal to log E y. So in conclusion, you can say log E y equal to what? X. So as you can see, we're getting same answers. Use method 1, you get that. Method 2, you get that. So if you feel you can't manage this one, at least manage that one. If you can't manage this one, manage that one. If you can't manage method 2, manage method 1. So that's what you're supposed to do. And that's question 5. Question 5, Roman numeral 2. Let's proceed. So we proceed. Make sure that you solve this one. Question 5(2). Make sure that you solve this one. (27/8). So if you want, you can use the two methods. You can use method 1, you can also use method 2 and see what we're going to get. Try this one. Try this one. Make sure that you do that. Make sure that you do that. Let's proceed. Question 6. Question 6. Write each of the following in exponential form. So question 6 is the opposite of what? Question 5, huh? So now question 6(1). Question 6, Roman numeral 1. We have log 2 6/4 equal to 6. Log 2 6/4 equal to 6. So even this one, we're going to use the same. We are saying z to the power y equal to x. This one we're saying is equivalent to y equal to log z what x, where we're saying x is our answer, y that's our exponent or power, y is our exponent or power, Z is our what? Our base. So now let's use the same concept even there. So we have log 264 equal to 6. So solving a question like that one, what you're supposed to do is to collect data. That's what is as important, collecting data. You have to know your Z, you're supposed to know your Y, and you're supposed also to know what? Your X. So now, let's do that. Data. Y according to this question is equal to what? Our Y is equal to what? So if you follow this one, we'll log 2. So our Z is equal to 2. Our X is equal to what? Our X is equal to 64. And our Y is equal to 6. So we've collected data now. We have Z equal to 2, X equal to 64, and Y equal to what? 6. So now let's substitute. The formula is there, the formula that you can use. So we have Z, Y equal to what? X. What is your Z is what? Your Z is 2. Your Y is what? Y is 6. Equal to, what is X? X is what? 64. You're done. That's the answer we want from you. So 2 to the power 6 equal to what? 64. Let's solve another question. So we solve another question. So let's proceed. Let's pick question that. Question 5. So this is question 6. We say question 6, Roman numeral 4. Just go down.
Does it usually go like that?
Just started back. This is what? Sorry. Is that doing? No. Continue. Okay. So let's do question 6 for Roman numeral 4. Question 6 for where are we? Where are we? Okay, we are there. We have log 27, 3 equal to 1 over 3. Log 20, log 27, 3 equal to 1/3. Let's proceed. We know that z to the power y is equal to what? Equal to x is equivalent to, we say y x, where we are treating x as what? We're treating x as our answer. We're treating y as our exponent. And z as our base. So now let's do that. The question is in log form. We want to change it in what? Changing it into what? Exponential. So now let's do this. What you're supposed to do here is to collect data.